right here we did normal force, and normal force is super easy here. Why? What makes all these situations pretty easy? Yeah, they're just opposite gravity, right? Okay, and then force applied kind of comes into effect and changes normal force. Okay, but here, what do you notice pretty quickly? Angle. Okay, so what are we going to have to do? Yeah, I'm going to have to get tricky with it. Okay, so, all right, let's draw an FBD. So we still have just a box sitting on a surface. Okay, it's still not that complicated of a situation. Okay, it's 10 kilograms. Let's remember all FBDs start with a dot. All right, and we draw the forces coming out of that dot. So we've got force of gravity. Put that acting downward. That is going to be mg and equal to 98 newtons. Okay. Then we have someone pulling on it. So we've got 40 newtons along a string at a 30-degree angle. Here's how we draw that. We draw it coming out of the dot again. And let's draw a little reference line in there. And this reference line is going to be parallel to the surface. Okay, so that's our 30-degree angle. And how do we do the symbol for this force right here? Somebody pushing or pulling on something. What do we call that? Force applied. So we'll call it FA. And that's equal to 40 newtons. Now that could be like the tension in a string or something, kind of like with my demonstration up front here. Okay, or it could be someone just grabbing the object and pulling up and over at an angle. Okay, now there's no way the person's gonna lift this, because they're only pulling, even if they were pulling straight up with 40 newtons, it's not gonna lift it off the surface. So what force still has to be here? Normal force has still got to be here. So we'll draw normal up, but I'm going to draw it less than mg, because since the person is pulling up on it, normal force is going to go down. F sub n. Okay, and we don't know its value yet. Here's what we need to calculate. We need to calculate the acceleration. Anytime we're asked about acceleration, we're going to have to deal with F net. We're also asked to calculate normal force, and we're going to do this first. We're going to do the normal force. We're being asked to analyze the vertical and the horizontal direction. Okay, usually when we got an angle and a hypotenuse and stuff like that, what are we probably going to have to do? Sine and cosine. Break it up into its components, its vector components. So I'm going to draw those dotted green here. We got a cosine and a sine component. Okay, so let's go over here and say x. And x is going to be equal to FA cos theta. Alright, and if we do that, we're going to do 40 cos 30. We'll punch that in just a second. And then for y, we are going to do FA sine theta. Okay, and so we have our two components. if you punch those into your calculator, let's do that real quick. All right, we get 34 and change. What if you don't get those numbers? You're probably in radians. Okay, and those come out in newtons. 34.6 newtons. And around 20 newtons. Alright, so now we have our x and y. Okay, now here's the deal, guys. The math, it's not that hard. You guys know how to do that. But we got to think about what are these components actually doing. Okay, who can raise their hand and tell me what the 20 newtons is doing in the situation? Okay, what do we got? Okay, the 20 newtons is horizontal though. Normal force is going to be vertical. Okay, so what is the 20 newtons? It's this right here. Oh, okay, I'm sorry. You're totally right. Good job. Okay, so the vertical, it's not normal force, but it is affecting normal force, right? It's helping normal force out. So in effect, it's reducing normal force, right? You guys really like it when I'm wrong, huh?
Yeah.
It's cool. I'm wrong all the time. All right, so the vertical force, it's reducing normal force. Okay, thanks, Colin. All right, now the x force, what is it doing? Yes, it's attempting to accelerate the box. And there's no friction here. All right, we deal with friction next. Okay, so since there's no friction, this is actually going to be our F net. We don't have to subtract out friction in this situation. Okay, so let's deal with the vertical first, and that'll get us normal force. And then we'll deal with the horizontal. Okay, so we're going to write an equation for the vertical forces. All right, that doesn't include any numbers. Okay, so downward we've got mg. So I'm going to say mg, that's the only force we have. And F net in the y direction is equal to 0. That's a fancy way of saying that all the vertical forces cancel. Alright, so we can say mg equals what? Well, the total equals 0. Okay, equals what's opposing it. What's opposing it is F normal and F A sine theta. Okay, now we know all of those values except F normal. So now we can find F normal. So let's do it. Fn is equal to, and all I'm going to do is subtract that to the other side. So I'm going to have mg minus Fa sine theta. Alright, and if we plug in our numbers here, we're going to do 98 minus Fa sine theta. Try not to mess it up this time. 20 newtons. And so we get a normal force of 78 newtons. Okay? So the 78 plus the 20 equals the 98. Alright, all the vertical forces cancel. Yes, which is what we did. We did mg minus the y value. Yep. Okay, now horizontal. Horizontal, we're going to deal with F net. Okay? Now later we'll throw friction into the mix, but here all we have to say is F net is equal to our horizontal component, which is FA cos. What can we always replace F net with? Newton's second law. MA. Okay? We can always replace F net with MA. Alright? And our FA cos theta, we already did that over here, so we won't do it again. That's our 34.6. And so our acceleration is equal to 34.6 over 10, coming out to 3.46 meters per second squared. Okay, and that's how you deal with forces at an angle, guys. You just have to split it into x and y and analyze how it affects normal force. Now another fun thing that we're going to do is, what if someone is pushing down on this at an angle? What do you suppose that does to normal force? It increases, and later we're going to learn that that is also going to increase friction, right? Okay. Oh, M is 10. It's our 10 kilogram box. Yep. Up here from the top. Okay, hopefully that helped.